Hey everyone, today we're going to be talking about polynomials. It's the first lesson of the polynomial section. So we're going to talk about the forms of a polynomial and some basic factors of a polynomial and what they look like. So let's start off with standard form. Standard form of a polynomial means that each term is only one power organized in decreasing powers. Okay, so let me make this a little bit bigger so it's easier to see. 3x to the fifth, number, letter, power. Negative 5x cubed, number, letter, power, and you can see the pattern follows. Notice there's not an x to the fourth in here. That's okay. We can skip if there's not something in there, but it has to go in descending order. So that's standard form of a polynomial. Factored form of a polynomial. Factored form of a polynomial is a group of factors all multiplied together. To convert factored form to standard form, we're going to multiply all the factors together, combine like terms, and then write it in largest to smallest power, so standard form. This is factored form. Why is it factored form? Because it's three factors. So let's multiply it out and then figure out what we have. We can't multiply all three, so let's just start with two of them. That's x squared plus 1 minus 4 is minus 3x minus 4. Now I have to multiply that by x minus 3. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. Negative 3x times x is negative 3x squared. Negative 3x times negative 3 is positive 9x. Negative 4 times x is negative 4x. And negative 4 times negative 3 is positive 12. That's not standard form because we haven't combined our like terms. Combine like terms, x cubed minus 6x squared plus 5x plus 12. Well, what kind of function is this? It's a cubic because it's x to the third, and it's a polynomial because there's more than 3 terms. So that's how to go from factored form to standard form. To go from standard form to factored form is much, much harder, and that's what we're going to work on for the next couple sections. Okay? Remember, the zeros of a function, also called the roots, also called the x-intercepts, and also called the solutions, can be found by setting each of the factors equal to 0 and solving. So let's find the zeros of the following functions. This one's really easy. What's easy about this? It's already in factored form. Because it's in factored form, I just set up a bunch of little problems. X minus 4 equals 0, x plus 8 equals 0, x minus 2 equals 0, 2x plus 5 equals 0, and 3x minus 1 equals 0. And then solve each problem. Here, this is x equals 4, x equals negative 8, x equals 2. This is going to be x equals negative 5 divided by 2. This is going to be x equals positive 1 over 3, or 1/3. So there are my 5 zeros, because I had 5 factors. But what about a problem like this? This is not in factored form. It's in standard form. Luckily, this is an easy one, so let's factor it. What's the very first type of factoring I taught you? GCF. The GCF is x. X squared minus 5x minus 66. Now I have simple factoring. I need two numbers that multiply to negative 66 and add to negative 5. That's negative 11 and positive 6. Now it's in factored form. So what are my 3 answers? Well, this is x equals negative 6, because that'll make 0. This is x equals positive 11, and that'll make 0. People always have trouble with this. If you set this equal to 0, you get x equals 0. Notice, I had a 3rd degree. I got 3 zeros. That's important. Zeros can be repeated. That's called multiplicity. For example, x minus 1, x minus 1, x minus 2. That has 4 zeros. It has a multiplicity, it has x equals 1, but there's there twice, so it's a multiplicity of 2, x equals 0, and x equals 2. Well, what does it mean to have multiplicity on a graph? Graphically, odd multiplicities cross the x-axis, and even multiplicities touch the x-axis. So here, this is x equals 0. It crossed the x-axis. This is x equals 1. Notice that it just touched the x-axis but didn't cross it. That's because it's got a multiplicity of 2, an even multiplicity. Over here, this is x equals 2. That only has a multiplicity of 1 because there's only one factor. That means it crosses. Things like that will help you a lot as you go through Algebra 2. Writing polynomials from zeros. Well, let's convert the zeros into factors because factors are what we work with. Multiply all the factors, combine like terms, and rewrite in standard form. So it's just like converting from factored form to standard form, except we have to write these zeros as factors first. So for this one, if a 0 is x equals 1, the factor is x minus 1. X equals 2 is x minus 2, and x equals negative 6 is x plus 6. So that's factored form. I have 3 factors. Start multiplying. X squared minus 2x minus 1x is minus 3x. Negative 1 times negative 2 is 2. And that still has to be multiplied by x plus 6. Distribute into that one, so I get x cubed plus 6x squared minus 3x squared minus 18x plus 2x plus 12. Notice, this is a trick that took me a long time to figure out, but I distribute into both of the little ones as I go. Why do I do that? Because now my like terms are grouped. X cubed plus 3x squared minus 16x plus 12. And that is my polynomial that has zeros of 1, 2, and negative 6. So that one's not too bad. Something to remember, imaginary solutions come in pairs. So let's write a polynomial with this 0. That's x minus 3 minus 4i. But since imaginary solutions come in pairs, if I have x minus 3 minus 4i, I have x minus 3 plus 4i. All imaginary answers come in pairs, plus or minus in front of the i's. Distribute. This takes some time. X squared minus 3x plus 4xi minus 3x plus 9 minus 12i minus 4xi plus 12i minus 16i squared. Let's do some cleanup. Some things should cancel out. Minus 12i and plus 12i are gone. Plus 4xi and minus 4xi are gone. I squared is negative 1, but negative 1 times negative 16 makes that a positive 16. So let's combine like terms. My answer is going to be x squared. Minus 3x and minus 3x is minus 6x. Plus 9 and plus 16 is plus 25. That's an equation that has a 0 at 3 minus 4i, and it also has a 0 at 3 plus 4i. Because imaginary answers come in pairs. So that does it for standard form and factored form, and zeros that relate to it. Next time we're going to talk about how to factor these things. There's a couple ways to do it. But for right now, guys, make sure you understand the relationship between zeros and factors. Thanks.